Welcome to the DIY Honda Garage channel. In this presentation, we will focus on DTC codes P2096 and P2097, which refer to post-catalyst fuel trim system errors in the Honda Civic model from 2016 to 2021. DTC P2096 indicates that the fuel trim system is too lean after the catalytic converter, while P2097 signifies that it is too rich. These codes help diagnose issues in the vehicle's fuel management system, which directly affects engine performance and emissions output. Understanding the underlying components involved, such as the air fuel sensor, AF sensor, and the secondary heated oxygen sensor, HO2S, is crucial for accurate troubleshooting. The strategies we will cover today will ensure a systematic approach to identify and fix the problem, enhancing the vehicle's performance while assuring compliance with emission regulations. DTC P2096 refers to the engine fuel trim system being too lean after the catalytic converter, whereas P2097 indicates it is too rich. The affected components primarily involved in this process are the air fuel sensor, designated as Sensor 1, which is responsible for measuring the air-to-fuel ratio before the exhaust gases exit the combustion chamber, and the secondary HO2S, or heated oxygen sensor, Sensor 2, which monitors the efficiency of the catalytic converter. The A fuel sensor is typically located upstream of the catalytic converter, while the secondary HO2S is found downstream. These sensors play a pivotal role in ensuring optimal fuel combustion, which directly affects engine performance, fuel efficiency, and emissions control. Proper functioning of these components is essential to maintain the overall efficiency of the vehicle. Several potential causes can trigger DTC P2096 and P2097. A faulty AFAC sensor, Sensor 1, might fail to correctly measure the air-fuel mixture, resulting in incorrect data sent to the Engine Control Module, ECM. Similarly, a malfunctioning secondary HO2S, Sensor 2, could misinterpret the exhaust gas composition, triggering these DTCs. Another possible cause is leaks or blockages in the exhaust system between these two sensors, which can dramatically affect sensor readings. Additionally, poor electrical connections, such as loose terminals or corroded connectors, can disrupt the signal transmission, resulting in erroneous DTCs. Identifying these causes is integral to effectively address the respective error codes. Symptoms of these DTC codes can manifest in several ways. The most immediate is the activation of the check engine light, CEL, which alerts the driver to potential issues. Poor engine performance may also be noticeable, often characterized by hesitation during acceleration or reduced power. Increased emissions can result from improper fuel management, potentially leading to failure in emissions testing. A rough idle, where the engine fluctuates while stationary, can signal an imbalance caused by the lean or rich condition indicated by the DTCs. Recognizing these symptoms can aid in quicker diagnosis and repair, ensuring the vehicle operates optimally while minimizing environmental impact. The first step in troubleshooting DTC P2096 and P2097 involves validating the problem. Begin by turning the vehicle to the on mode, allowing the onboard systems to initialize. Utilize the Honda Diagnostic System, HDS, to clear any existing DTC codes. After clearing, start the engine and maintain an engine speed of 3,000 RPM without load, ensuring that the vehicle is in either park or neutral for continuously variable transmission, CVT, or in neutral for manual transmission. Once the radiator fan activates, transition into a test drive, ensuring the engine coolant temperature exceeds 158 degrees Fahrenheit, 70 degrees Celsius, while also keeping the vehicle speed steady between 15 to 75 miles per hour for at least 69 seconds. Finally, monitor the onboard diagnostics OBD status for DTC P2096 or P2097 using the HDS to confirm any active codes. In this second step, start the engine again to perform a more focused check on the air-fuel mixture. Maintain the engine speed at 3,000 RPM without any load, similar to the previous step. Ensure that the air conditioning is off and all unnecessary electrical loads are disabled to guarantee that the test reflects true operating conditions. Utilize the HDS to perform the cylinder A fuel test in the inspection menu 3 separate times. This test assesses the air-fuel ratio across the cylinders, allowing for variations that might indicate miscalibrations within the fuel system. If the results from this test return as OK, proceed to step 3. Should your results be negative, further troubleshooting for DTCs P2019C, P2019D, P2019E, and/or P2019F is required. Next, you will need to switch the vehicle to the off, lock mode to safely carry out physical checks within the exhaust system. Focus on identifying any leaks that may exist between the A5th sensor, sensor 1, and the secondary HO2S, sensor 2, as leaks can lead to erroneous readings of the exhaust gases. Look for signs of clogging or blockage in the exhaust system, which can also hinder optimal airflow. These conditions fundamentally impact sensor performance and could trigger the error codes in question. If any issues are discovered, repair or replace the exhaust components accordingly to restore proper operation of the fuel trim system. The fourth troubleshooting step calls for a substitution test of the AF sensor, sensor 1. Replace the original sensor with a known good unit to determine if the component is indeed faulty. Ensure to reconnect all electrical connectors before proceeding. Once you've done so, switch the vehicle back to the on mode, allowing the system to prepare for further diagnostics. Utilize the HDS to reset the powertrain control module, PCM, which is responsible for managing engine and transmission behavior. After resetting, perform the PCM idle learn procedure to help the control module recalibrate itself based on current operational parameters. This step is essential for ensuring the vehicle can accurately manage fuel trim once the new sensor is in place. The final repair verification step ensures that all previous steps taken have resolved the issue effectively. Begin by starting the engine once again and holding it at the same 3,000 RPM for a consistent period, similarly to earlier diagnostics. Engage in a test drive while following the established conditions. Ensure engine coolant temperature exceeds 158 Fahrenheit, 70 degrees Celsius, and maintain a steady speed between 15 to 75 miles per hour, 24 to 120 kilometers per hour. After completing the drive, utilize the HDS to monitor the OBD status for DTC P2096 and/or P2097. A pass indication from the HDS will confirm successful resolution of the previously logged errors. If the DTCs persist, further investigation is necessary, possibly leading back to reevaluation of previous steps. Preventive maintenance is key in avoiding future occurrences of DTC P2096 and P2097. Regular inspections of the AF sensor will help catch potential issues before they escalate into full failures. It's also wise to routinely check the health of the exhaust system, looking specifically for any signs of leaks or blockages that could disrupt the normal functioning of the vehicle. Furthermore, Ensure that all electrical connections associated with these sensors are clean and secure, preventing faulty readings that could trigger diagnostic trouble codes. Timely replacement of faulty sensors when warning signs are detected can significantly enhance vehicle performance and reduce the risk of emissions-related issues. To summarize, troubleshooting DTC P2096 and P2097 requires a systematic approach to diagnosing the root causes of post-catalyst fuel trim system issues. Key components like the AF sensor and the secondary HO2S are vital to maintaining proper fuel and emissions management. The ability to monitor the onboard diagnostic status frequently will aid in catching any potential issues early. Finally, establishing a routine for preventive checks serves as an investment in your vehicle, allowing for more reliable performance and significant cost savings in future repairs. By adhering to these guidelines, you can ensure the longevity and efficiency of your Honda Civic. Please like and subscribe to the channel. See you next time.